Let me study the question. When 1 mole of C3H8, that is propane, at 300 Kelvin is burnt with stoichiometric amount of oxygen at 300 Kelvin to form CO2 and H2O, the adiabatic flame temperature is 5975 Kelvin. If propane is burnt under the same conditions but with excess oxygen, the adiabatic flame temperature will be option A equals to 5975 Kelvin irrespective of the amount of excess oxygen. Option B higher than 5975 Kelvin irrespective of the amount of excess oxygen. Option C lower than 5975 Kelvin irrespective of the amount of excess oxygen, and option D higher or lower than 5975 Kelvin irrespective of the amount of excess oxygen. So let us try to find the answer. So adiabatic flame temperature refers to the maximum temperature achievable theoretically during the combustion process taking place at constant pressure. Here it is assumed that no energy is lost to the outside environment. So from the data, 1 mole of C3H8 reacts with stoichiometric amount of oxygen to get carbon dioxide and water. So we need to find the stoichiometric amount of oxygen. So let us try to equate this. Here it will be 3 carbon dioxide and 4 H2O. So number of oxygen molecules will be 5. So the question here is, what happens to adiabatic flame temperature TFL when excess oxygen is used and under the same conditions? So we need to know the effect of excess oxygen on adiabatic flame temperature TFL. So let us know the factors affecting adiabatic flame temperature. So these are the factors affecting adiabatic flame temperature. The first one is equivalence ratio, which is the ratio of fuel to air, and the other factors are the initial temperature and the chamber pressure. In this question, it is asked to find the effect of excess oxygen on the adiabatic flame temperature, which in other words, we need to find the effect of equivalence ratio on adiabatic flame temperature. So this graph represents the effect of equivalence ratio on adiabatic flame temperature, and in this graph the equivalence ratio is plotted on x-axis and the adiabatic flame temperature is plotted on y-axis. So when the fuel, in this case propane, reacts with stoichiometric amount of oxygen, the equivalence ratio will be equal to 1. From this graph we can see that the adiabatic flame temperature will be maximum when the equivalence ratio is 1. As we know, when the equivalence ratio is less than 1, that is this region, the air will be higher than that of fuel, that is this region will be the fuel lean region. And when the equivalence ratio is higher than 1, that is this region, the fuel will be in excess. When the fuel is burnt with excess oxygen than the stoichiometric oxygen, the equivalence ratio will be less than 1 and the fuel lean condition will be achieved. So the adiabatic flame temperature decreases as shown in this graph. So when propane is burnt under the same conditions but with excess oxygen, the adiabatic flame temperature will be lower than 5975 Kelvin irrespective of the amount of excessive oxygen. So the answer is option C.